Hello viewers, in today's class we are going to discuss two important problems from application of derivatives related to increasing and decreasing functions, right? And these two problems are going to be very useful for the beginners, right? And moreover, these two problems are very important, right? So let us start. So here we are given two functions, right? And we have to find the intervals in which these two functions are increasing and decreasing, right? So here the first function is a polynomial function, which is a cubic polynomial of degree 3, right? So here f of x is x cube plus 3x square plus 3x minus 8, and the domain is x belonging to the set of real numbers, right? And the second function is the product of a polynomial function x and the exponential function, so x times e raised to minus x, and here also the domain of the function is the set of all real numbers, right? So let us take these two problems one by one. So before solving these two problems, let us quickly see the conditions for a function to be increasing and decreasing, right? Now see, suppose we have a function, say y is equal to f of x, which is defined in some domain D, right? And let this domain D be the set, say a to b, right? And the function is defined in this interval. Now the function is said to be increasing if the derivative of this function f of x, the derivative is f prime of x if it is greater than 0, right? For all x belonging to this interval, right? And similarly, the function is said to be decreasing if the derivative is less than 0, right? So here we are dealing with the concept of strictly increasing and strictly decreasing, right? So this function is said to be strictly increasing if f prime of x is greater than 0, and strictly decreasing when f prime of x is less than 0, right? So increasing function implies that the slope must be greater than 0, or the slope should be positive, right? So for increasing functions, the slope of the tangent should be positive, and for the decreasing functions, the slope should be decreasing, or in other words, we can say that the slope of the decreasing functions, the tangent line should be less than 0, right? So we have this function f of x, right? Now let us find out the derivative of this function. So f prime of x is equal to 3x square. The derivative of x cube is 3x square, and the derivative of x square is 2x, so this is 6x, and here the derivative of x is 1, so we have simply 3, and the derivative of 8 is 0, being a constant, right? So the derivative is equal to 3x square plus 6x plus 3, right? So now let us take 3 common. So we have x square plus 2x plus 1, right? And now we can express x square plus 2x plus 1 as x plus 1 whole square, right? So now we see that the derivative of this function is equal to 3 times x plus 1 whole square, right? Now let us see this quantity. So here we have x plus 1 square, and we know that the square of any quantity is always positive, right? So we have f prime of x is equal to 3 times some positive quantity, right? Because x plus 1 is whole square is always greater than 0 or equal to 0 for all x belonging to the set of real numbers, right? So being a square quantity, this quantity is always be positive or equal to 0 for all x belonging to R. So the derivative f prime of x is equal to 3 times some positive quantity, and this is another positive quantity, right? So we conclude that the derivative of this function is always greater than 0 or equal to 0 for all x uh, belonging to the set of real numbers, right? So this function is always increasing for all values of x belonging to the set of real numbers. So the derivative is always greater than or equal to 0. So we can conclude that this polynomial function of degree 3 is always increasing function for x belonging to the entire number line, that is minus infinity to positive infinity, right? So this is the interval in which this function is increasing. So this function can never be decreasing, right? So it is always increasing, and this is the interval. This interval is also equivalent to the set of real numbers, right? Let us take the second problem. So now the second function is f of x is equal to x times e raised to minus x, right? Now let us calculate the derivative of this function. So this is the product of two functions, so we can apply the product rule, right? So the product rule goes like this: if u and v are two functions of x, then we have the product rule as u, then dv by dx, then v, and du by dx, right? So here we have x, then derivative of e raised to minus x, then e raised to minus x, and derivative of x. So f prime of x is equal to x. The derivative of e raised to minus x is minus e raised to minus x, and here we have e raised to minus x, and the derivative of x is 1, right? So we have f prime of x is equal to minus x e raised to minus x plus e raised to minus x. So this is f prime of x. So we can take e raised to minus x common. So we have e raised to minus x, and we have minus x plus 1, right? So this can also be written as minus x plus 1 divided by e raised to x, right? So now viewers, this function that is f of x is increasing when f prime of x is greater than 0, right? So it implies that this quantity, that is minus x plus 1 divided by e raised to x, is greater than 0, right? And we know that this quantity, that is e raised to x, is always greater than 0 for all x belonging to the set of real numbers, right? Because the exponential function is always positive, or it is always greater than 0 for all values of x belonging to the set of real numbers, right? So for minus x plus 1 divided by e raised to x to be greater than 0, it means this quantity, that is minus x plus 1, must be greater than 0, right? For f prime of x to be greater than 0, the sign depends on this quantity, that is minus x plus 1, right? So we have 1, taking this negative sign to this side, we have minus 1 greater than x, or we can say that x is less than 1, right? So if we draw the real number line here, we have minus infinity, here we have plus infinity, and here we have the point 1, right? So for x less than 1, right, that is this portion. So in this portion, the function is increasing, right? So the function is increasing for x less than 1, right? So this is the interval that is from minus infinity to 1. The function is increasing, right? And if we include the point 1, then at x is equal to 1, the derivative is 0, right? So we can also write this interval as x belonging to minus infinity to 1, right? Okay, and for x greater than 1, the function is decreasing, right? So in this portion, that is x greater than 1 or x belonging to the interval 1 to infinity, the function is decreasing, right? So decreasing means the derivative is less than 0, right? So we can conclude that this function x times e raised to minus x is increasing for x less than 1 and decreasing for x greater than 1. So here one important thing is that when we have x is equal to 1, that is this point. So if we take x is equal to 1 in this expression, then we see that f prime of 1 is equal to 0, right? So x is equal to 1 is the critical point for this function f of x, right?